Hey there, in this demo, we are diving into radar signal simulation using Keysight VXG-C M9484C signal generator and the embedded pulse building app. I will start with a quick walkthrough of the software, then jump into a live demo. To launch the app, click the cube icon on the top bar and select Pulse Building. Start in the Pulse tab to design your radar pulse. You can easily add, delete, copy, or rename pulse items. Next, head to the Pattern tab to build pulse sequences. Patterns can be based on either pulse items or other patterns, and you can manage them just as easily. Then, go to the Waveform tab to choose which pattern to output as a waveform. Set your sample rate, and in the Routing tab, pick the RF channel you want to use. Finally, hit Generate, and your waveform will play on the selected RF channel. The Pulse Building app now supports Legacy Signal Studio N760B. Just hit the folder icon to import your old project file. Your settings load instantly. Ready to go! The Pulse Building app lets you export pattern settings as a CSV format. Just click the folder icon to save your file. Then import it into any project for a fast setup. Easy and efficient. Let's take a closer look at designing a single pulse. The Pulse Building app offers multiple pulse types, like trapezoidal and raised cosine, and lets you set pulse width, rise and fall time. You can also load a custom profile or IQ data with your own sample rate for full control. Radar systems use pulse modulation like amplitude, frequency, or phase to boost detection, resolution, and resistance to interference. Popular techniques include FM-Chirp, barcode, and frame code. The Pulse Modulation app gives you a wide range of modulation types, including custom options. You can easily add, delete, or import modulation data using the GUI or a CSV file. For FM-Chirp, you can choose constant deviation or go with a nonlinear custom method. You can also define barcode order and frame code along with modified versions like P1 through P4. These help encode data, reduce ambiguity, and improve target recognition in a complex environment. Now let's take a closer look at PRI patterns used to modulate timing between radar pulses. The Pulse Building app offers several types. Linear PRI, where you set pulse start and stop time. Bursted PRI, which groups multiple pulses into bursts with defined burst interval. Stepped PRI, letting you choose the number of steps and the number of pulses per step. Staggered PRI, where you set varying repetition intervals for each pulse. These options gives you full control to simulate complex radar timing scenarios with ease. Now let's talk frequency hopping, used to shift transmission frequencies between radar pulses. The Pulse Building app supports several hop types. Linear hop, where you set start and stop frequencies. Staggered hop, where you define specific hop value in a table. Stepped hop, where you set the start frequency, step size, number of steps, and pulses per step. If the total pulse count is less than the number of steps multiplied by the pulse per steps, it will truncate automatically. This option gives you full control to simulate radar signals that resist jamming, reduce interception, and perform better in complex environments. Radar systems rely on antenna scan patterns like circular, conical, raster, and sector scans to efficiently cover civilians' areas, enabling accurate detection, tracking, and situational awareness across different zones. The Pulse Building app supports multiple scan methods for realistic simulation. You can set the scan rate, receiver location, and view pattern diagrams and configuration graphs to better understand each setup. For raster scan, the radar beam sweeps line by line, bottom to top with a bar width, like how a screen draws an image, ideal for the rectangular coverage. Sector scan to focuses on a well-shaped area, perfect for the targeted civilians instead of full 330-degree coverage. So both support bidirectional and unidirectional modes. You can also define custom scan patterns, including varying power levels, and even sequence multiple scan types to simulate complex real-world scenarios. Next, let's look at a live demo to generate and validate a complex radar signal pulse sequence. In the Pulse Building app, I've created 3 items under multiple patterns, each with a different modulation type. The first item is a CW wave without modulation with 8 pulses, each pulse with 5 microseconds. It uses a staggered PRI and a power scale of 0 dB. The second item uses linear FM-Chirp modulation with 4 pulses, a constant PRI 25 microseconds, and a power scale of -2 dB. The third item is barcode modulation with 3 pulses and a constant PRI 30 microseconds, and a power scale of -3 dB. I've selected multiple patterns as a waveform output here, set the sample rate to 500 MHz, and routed it to F-port 2. The radar signal is now playing on group 2 memory index 1. I've set the frequency and the output power. Next, let's switch to access pulse measurement to verify this radar signal. After setting frequency, measurement type, pulse count, and enabling modulation types buckle here. The demodulation results match perfectly. You will see 8 CW pulses nearly at -5 dBm, followed by 4 linear FM-Chirp pulses nearly at -7 dBm, and 3 barcode pulses nearly at -8 dBm. So pulse width and PRR patterns are exactly as configured. Xapps also offers detailed metrics, but for this demo, we are focusing on signal generation. From flexible pulse creation to skippy automation and high performance, the VXG-C with Pulse Building app delivers a powerful, user-friendly radar emitter solution. Whether you are working on airborne, automotive, or EW radar system, this is the platform to trust. Want to learn more or start free trial? Visit our website. Thanks for watching.